See, in the previous class, we have discussed the T and the TM modes, and then what are the field patterns depending upon the mode number one not zero. That is dominant mode for TE case is the TE10, and the dominant mode for TM is the TM11. You know the dominant mode. Dominant mode is nothing but the dominant mode is nothing but the mode which is having a lowest cutoff frequency. For TE mode, TE10 is the dominant mode. For TM11 is the dominant mode. Okay, now again we have to find out the what are the characteristics of the characteristics of T and the TM. T and the TM, as in the previous case for the parallel plane waveguides, there the narrow dimension B is not present. Okay, now here both the dimensions C and B are present. Now the relation between gamma and H is, and H square equal to gamma square plus omega square mu naught epsilon naught. Gamma square plus omega square mu naught epsilon naught. Harika. Sumant, is it audible?
Yes, ma'am.
Okay. See, from this one, gamma equal to square root of x square minus omega square mu naught epsilon naught. And again here we have assumed h square equal to b square plus a square as in the derivation as per the derivation in this one. In this previous one. That is, we have set b equal to m pi by a and a equal to n pi by b, and here we have assumed the both products. Like this, we have assumed the h square equal to b square minus a square. This is h square xy. It is dou square ay by dou y square. That simplification we are using here. That simplification we are using, that is b square equal to h square minus a square, and here h square equal to a square plus b square minus omega square mu naught epsilon naught. If you substitute b equal to 0, you will get the gamma as for the parallel plane waveguides. Now gamma equal to alpha plus j beta, that is equal to h square is m pi by a whole square plus n pi by b whole square minus omega square mu naught epsilon naught. Now here at low frequencies, this factor will be high, and this factor is lower, then alpha plus j beta is the real part. And this value of alpha plus j beta depends upon the value of m and n, where m and n are the mode numbers. M and n are the mode numbers. Now, as the frequency is increasing, this factor is dominating compared to this factor. Then omega square mu naught epsilon naught minus m pi by a whole square minus n pi by b whole square. Now, if you take at the cutoff frequency, omega equal to omega c, beta equal to 0. Now, cutoff frequency means the frequency at which the wave propagation ceases. That means beta equal to 0. From above this frequency, the wave propagation will occur. Now, at omega equal to omega c, beta equal to 0, or omega c square, because omega equal to omega c, that is at the cutoff frequency, omega c square mu naught epsilon naught minus m pi by a whole square minus n pi by b whole square equal to 0. Now this is equal to omega c square mu naught epsilon naught equal to m pi by a whole square plus n pi by b whole square. Now you can take the omega c equal to 1 by square root of mu naught epsilon naught square root of m pi by a whole square plus n pi by b whole square. omega c is 2 pi fc, and if you take out the common pi, and 1 by square root of mu naught epsilon naught is the c, so pi will be getting cancelled, so square root of m pi by a whole square plus n pi by b whole square. Fc equal to c by 2 square root of m by a whole square plus n by b. This is the cutoff frequency. If you want to transmit any frequency, the frequency of operation should be greater than the cutoff frequency. The frequency of operation should be greater than the cutoff frequency. Then only, that means for different values of m, you will calculate the cutoff frequency. If the frequency is greater than this cutoff frequency, then only that mode of propagation will be possible. Then if you can understand well after solving the problems. Now this is the cutoff frequency. Now the cutoff wavelength, lambda c equal to c by fc, that is called the cutoff wavelength. That is lambda c equal to c by fc. Cc will be getting cancelled with 2 by square root of m by a whole square plus n by b whole square. And frequency should be greater than fc, and lambda c should be lambda c should be less than lambda. That means frequency should be greater than fc, but lambda c should be less than lambda. That is, the below that cutoff wavelength only the frequencies will be passed through the waveguide. Now the guided wavelength lambda g, that is equal to lambda g equal 2 pi by beta, lambda g equal 2 pi by beta. Now lambda g equal 2 pi by square root of omega square mu naught epsilon naught minus m pi by a whole square minus m pi by b whole square. This is the beta. This is the beta. You have to substitute. Now here the phase velocity, Vp equal to omega by beta. Now here beta, if you simplify, because at the operating frequency omega c naught omega c square omega c square mu naught epsilon naught equal to m pi by a whole square plus n pi by b whole square. Now if you substitute for this one omega c square mu naught epsilon naught, this is the same procedure if you adopt for the whatever you have done for the guided waves, you will get omega by beta equal to 1 by square root of 1 minus fc by f whole square. Because here you have substituted m pi by a whole square plus n pi by b whole square as omega c square mu naught into epsilon naught. Okay, now the group velocity Vg equal to c square by bvp, and we have derived already Vg into Vp equal to c square. Vg into Vp equal to c square. Now Vg equal to c into square root of 1 minus fc by f whole square. Now here the another important parameter which you will not get in the guided wave is the wave impedance. What is the impedance offered for that wave in the waveguide? What is the impedance offered for the wave in the waveguide? Now it is defined as the ratio of strength of electric field in one direction to the strength of magnetic field in the transverse direction. Always Z is nothing but the ratio of electric and the magnetic fields. It is the ratio of electric and the magnetic fields. Now when the wave is propagating in the Z direction, the electric and magnetic fields are transverse to the direction of propagation. Z in the Z is the impedance. You can define Z is the impedance. It is the ratio of magnitude of Ex by Hy. This is the Z direction. So the electric and magnetic fields are transverse to the direction of propagation. Now, if you take the magnitude of the electric field and magnitude of the magnetic field, ZTM, for the TM mode, if you take the ratio, you will get this equation. For ZTM, you will get this ratio. That's what we have calculated in the previous session. Okay, now if you simplify this one, this m pi by Ca will be getting cancelled. That is h square will be getting cancelled. Gamma by omega epsilon. Because you have to take the magnitude, gamma equal to alpha plus j beta, you have to take the magnitude, because at high frequencies only beta is the dominant factor, beta by omega epsilon naught. Or you can say beta if you substitute, in terms of square root of 1 minus fc by f whole square. Now here this is equal to ZTM equal to, if you simplify, that is C equal to 1 by square root of mu naught epsilon naught. And if you substitute omega equal to 2 pi f minus omega c 2 pi fc whole square, if you simplify the expression, and in the denominator also, you have the omega equal to 2 pi f. If you simplify, because it is epsilon naught, see the square root of mu 1 by mu naught epsilon naught. That square root of epsilon naught, this epsilon naught will be getting cancelled. You will get mu naught by epsilon naught square root of this omega. If you take it inside the square, inside the square root, it is the omega square. Omega square divided by omega square, 1 minus omega c square by omega square. Then it is the 1 minus fc by f whole square. And you know the formula for the intrinsic impedance that you have calculated for the EMF theory, that is equal to square root of mu naught by epsilon naught. So it is equal to eta square root of 1 minus fc by f whole square. Now similarly in the same, this is the wave impedance. This is the equation for the wave impedance. Eta into square root of 1 minus fc by f whole square. And here the frequency of propagation is always greater than the fc, always greater than the fc. So this is the value less than 1. So 1 minus this one, that is eta equal to 125, eta equal to 125. So always ZTM is always less than the eta, or it is always less than the 125. Now if you take the ZTE mode, if you take the in the same manner for the transverse electric waves, again the Ex by Hy if you take, these are the magnitudes of the electric field j omega mu naught by H square. Now if you see the expression Ex for the TE mode, this is the Ex if you take only the magnitude for the TE mode of propagation. Now here it is j omega mu naught Cn pi by b into H square. And this, because we are taking the magnitude, this is equal to unity. Like this, if we take only the magnitude, if you substitute in these equations, you will get Ex by Hy, Ex by Hy. And here this, again this expression is modified as gamma by omega epsilon. Again it is approximated to gamma equal to alpha plus j beta, that is equal to, again beta, only we are considering the magnitude divided by omega epsilon naught. This is also at high frequency. This is also at high frequency. Why? Because is at low frequencies alpha is also the coming into picture. At high frequencies only beta. That means when the wave is propagating within the waveguide, only the beta factor is only considered. Only the beta factor is only considered. Now here, now the ZTM is this one. Now here ZT equal to omega mu naught by with the gamma, that is equal to beta. So mu naught is permeability at the permeability of the free space, and the beta if you substitute, that is square root of omega square minus omega c square by c. Now if you simplify, c equal to 1 by square root of mu naught epsilon naught. Mu naught, this is 1 mu naught will be getting cancelled. You will get square root of mu naught by epsilon naught 1 by 1 minus fc by f whole square. Because if you take out in the denominator omega by omega square 1 minus fc by f whole square. Now ZT equal to eta by square root of 1 minus fc by f whole square. This is the expression for the wave impedance for the TE mode. Wave impedance for the TE mode. That is here eta by some factor less than 1. So ZT is always greater than the eta. ZT is always greater than eta. Whereas ZTM is always less than eta. Okay, these are the characteristics of TE and the TM waves. These are the characteristics of TE and the TM waves. Now you do one problem so that you can understand. Not so that you can understand. Not done. Note down and solve the problem by using the wave equations. If the note down if the dimensions of note down if the dimensions of rectangular waveguides are 3.5 centimeters into 2 centimeters and the frequency of operation is 1 minute. Solve the problem. ఇది పెట్టి దీంట్లో
లంచ్ తర్వాత మీ అక్కడికి వచ్చేస్తాను.
మేము ఉంటాం రేపు లంచ్ తర్వాత వాళ్ళు ఉన్నట్లు. రేపు మీరు రావట్లేదా? మళ్ళీ ఎప్పుడు వస్తారు? మళ్ళీ గురువారం. ఇప్పుడు దీన్ని ఏదైనా ఒకటి పెట్టి టెస్ట్ చూస్తే ఒకసారి నేను ఏమన్నా ఇదైతే డిలీట్ చేస్తుంది. అంటే నా క్లాస్ 11:30కి అయిపోద్ది. సరే అయితే మీ రూమ్ లోనే ఉంటారా? సరే నేను వస్తా, అటు వస్తానండి. Determine all the possible T and TM modes that can be propagated within the waveguide. Now here, depending upon the dimensions of the waveguide, that is A equal to 3.5 and B equal to 2 centimeters, and the frequency of operation is 10 gigahertz. Find first the cutoff frequency FC. First find the cutoff frequency FC. If that frequency F equal 10 gigahertz is greater than the cutoff frequency for the value of M and N, then only that mode will be propagating. Now, if you take, that means the cutoff frequency should be less than F, or lambda C should be greater than F. That is F equal to lambda C, lambda equal to C by F. Either you can calculate in terms of the FC or in terms of the lambda C. Now, here if you take the lambda C, that is 2 by square root of M by A whole square plus N by B whole square. Now, here when M equal to 0 and N equal to 0, that is this is equal to 0, lambda C equal to infinity, so it is not at all possible. Now, if you take M equal to 0, this is M equal to 0, this is 0, N equal to 1, this is 1 by B whole square. That is here 2B. B is the value of the dimension is the 2, so it is equal to 4. That is here lambda C is the lambda C for this mode is 4 centimeters and lambda equal to 3 centimeters. So lambda C is greater than lambda. So this can be propagated. Now for this mode of propagation, now this mode will be possible. Now calculate for m equal to 1 and n equal to 0. M equal to 1 and n equal to 0. Screen share అయిందా?
Yes, ma'am. Sharing.
Okay. Viనండి, the model is same. The model is the same. Either you can calculate in terms of FC or it is in terms of lambda. Okay. Now here lambda c, lambda c is greater than lambda. So it is equal to, again, for m equal to 1 and n equal to 0. That is 2 by 1, m equal to 1 means 1 by a whole square plus n equal to 0, this is 0. So it is 2 into a, the value of a equal to 2 into 3.5, that is equal to 7 centimeters. Now here 1, that is m equal to 1 and n equal to 1, that is 2ab by a square plus b square. If we calculate, you are getting the 3.47 centimeters. Okay, the next one is m equal to n equal to 0. That is n equal to 0 means this is 0. That is here 2 by 2 into a, that is 3.5 centimeters. Like this, you have to calculate for all the possible modes, and the condition is lambda c should be greater than lambda. If you calculate for higher values of this one, for higher values of this one, this condition may not be satisfied. This condition may not be satisfied. When this condition is satisfied, only those modes of propagation will be possible. Those modes of propagation only will be possible. Okay, all the modes for this dimension, it cannot be possible. It cannot be possible. Okay, like this, if you take the another problem, that is here, a tunnel is modeled as an 8 feet metallic rectangular waveguide with the dimensions of a equal to 8 meters and b equal to 16 meters. Determine whether the tunnel will pass a 1.5 megahertz for broadcasting the signal. Okay, the bandwidth is 120 megahertz FM broadcast signal. Now here a equal to 8 and b equal to 16. Now in general, now the broader dimension is 16 and the narrow dimension is 8. Now here in some books they will take the b as a broader dimension, a as a narrow dimension, or in some question papers also they can interchange. Now you have to consider the allow the frequency, the lowest cutoff frequency mode, that is when b equal to a is, now if you calculate for 0, 1, that means m equal to 0 and n equal to 1, that is equal to the 32 meters. Now here the cutoff frequency C by FC, this is 9.375 into 10 power 6. Now here if you take the, this is the band of frequency 1.5 to 120 megahertz. Now this is the cutoff frequency is in between these two. So in between these two, now in between these two, that means here 1.5 to 120 megahertz, it is allowing the frequencies of broadcasting, because it is acting as a high pass filter. It is acting as a high pass filter. Like this, here we have to calculate the frequencies. Now if you take the another one, calculate the cutoff frequency for dominant mode in a rectangular waveguide, that is a equal to 4 and b equal to 2. Again lambda c you have to calculate. That is for the dominant mode T10, m equal to 1 and n equal to 0. So it is 2 into a, that is equal to 8 centimeters, fc equal to c by lambda. So this is equal to 3.75. That is the, this is the cutoff wavelength and this is the cutoff frequency. This is the cutoff frequency. Like this, we have to calculate for different modes of propagation. What is the cutoff frequency and the cutoff wavelength? Okay. ప్రాబ్లం చేస్తారా? Note down one problem. Calculate the Note down one problem. Calculate the lowest cutoff frequency and determine the mode closest to the dominant mode of rectangular waveguide .1 centimeter into 2.4 centimeters. Calculate the cutoff frequency of the dominant mode. Here the dominant mode is the T10 mode. Calculate the cutoff frequency, FC. Venkatesh, Jaisimha, what is the answer? Manoj, Harshita, Purna, anyone can calculate and tell me the answer? What is the answer? Nobody is responding. Out of 130. Yashwant. Sumant.
మ్యామ్
Is it audible? ఏంటి ఎవరు అసలు చిన్న ప్రాబ్లం కూడా క్యాలిక్యులేట్ చేయట్లా అంటే ఎవరి దగ్గర ఏం క్యాలిక్యులేటర్స్ లేవా?
రైట్ ఉన్నా మ్యామ్ క్లాస్
రేపు క్లాస్కి వచ్చేటప్పుడు అందరూ క్యాలిక్యులేటర్స్ దగ్గర పెట్టుకోండి. క్యాలిక్యులేటర్స్ నోట్బుక్ రేపు అంతా ప్రాబ్లమ్స్ చేపిస్తాం.
ఓకే మ్యామ్.
అందరూ కూడా ఆల్ ఆఫ్ యూ మీరందరూ ఈ లింక్ లో ఉండిపోండి. పద్మ మేడం జాయిన్ అయిపోతారు. మళ్ళీ బయటకు వెళ్ళడం లోపల రావటం దీనికి ఎందుకంటే 132 మెంబర్స్ ఉన్నారు. అటెండెన్స్ టయానికి వచ్చేస్తున్నారు. సుమంత్ టేక్ ద అటెండెన్స్. మా అందరూ రేపు క్యాలిక్యులేటర్స్ నోట్బుక్ పక్కన పెట్టుకోండి ఏంటి. నేను ప్రాబ్లం ఆన్సర్ ఎవరు చెప్తే వాళ్ళకే ఇస్తా.
మ్యామ్స్ తీసుకోనా
తీసుకో.
సిరీస్ L1
present ma'am.
16 series 76 మ్యామ్. 16 series లో 76 ఆప్షన్ మ్యామ్.
ఓకే
17 series
నిన్న కూడా ఆప్షన్టే కదా?
నిన్న కూడా ఆప్షన్
అంటే రోజు వస్తున్నాడా? మా రోల్ లిస్ట్ తన నెంబర్ లేదు
అంటే తన డౌట్ మ్యామ్. మొన్న లెటర్ వచ్చిందంట మ్యామ్. సో డౌట్ జాయిన్ అవ్వాలో లేదు.
ఓకే ఓకే
16 series మ్యామ్. 62 63
ఇప్పుడైతే ప్రజెంట్ మేడం గట్టిగా చెప్తున్నారు. ఇందాక నుంచి నేను పేర్లు పిలిస్తే ఒక్కళ్ళు కూడా మాట్లాడలేదేంటి? ప్రాబ్లం ఒక చిన్న ఫార్ములా చేయమంటే అమ్మా రేపు అందరు క్యాలిక్యులేటర్స్ దగ్గర పెట్టుకోండి.
63 63 64
Present.
65
Present ma'am.
66
Present ma'am.
67
Present.
68
Present.
69
Present.
70
Present.
71
Present.
72
Present ma'am.
73
Present.
74
Present.
75
Present.
మ్యామ్ 76 లెఫ్ట్ హ్యాండ్ కనెక్షన్.
ఓకే
77
Present.
78
Present.
79
Present.
80 లేయర్ మ్యామ్. 81
Present.
82
Present.
83,
మీరు లాగౌట్ అవ్వకండి, మేడం జాయిన్ అయిపోతారు.
Present.
84,
Present.
85, 86,
Present.
87, 88, 88, 88 absent, ma'am.
ఓకే.
89,
Present, ma'am.
90, 90,
ఇది సెల్ ఫోన్ పనిచేస్తుంది.
90 absent, ma'am. 91,
ఎంత 80 అబ్సెంటా?
90, ma'am.
ఓకే ఓకే.
91,
Present.
విండోస్ 10 అయితేనే పనిచేస్తుంది. మరి ఆ రోజు ఎలా పనిచేస్తుంది?
92,
Present.
93, 94, 94, మ్యామ్ 94 ఉన్నాడు మ్యామ్, కానీ రెస్పాండ్ అవ్వట్లేదు. 95,
Present.
96,
Present.
97,
Present.
98,
Present.
99,
Present.
A0,
Present.
A1,
Present.
A1,
Present.
A2,
Present.
A3,
Present.
A4,
Present.
A5,
Present.
A69 మ్యామ్, A7, A7,
A6 అబ్సెంటా?
నేను మ్యామ్ A69 మ్యామ్.
ఓకే ఓకే అవును.
A7, A7 absent, ma'am. A8,
Present.
A9,
Present.
A9, B0,
Present.
B1,
Present.
B2, B2, B2 absent, ma'am. B3,
ఓకే.
Present.
B4,
Present.
B5, B6 clear, ma'am. B7,
Present.
B8,
Present.
B9, B9, B9 absent, ma'am. B0,
Present.
LE13,
Present.
14,
Present.
15,
Present.
16,
Present.
17,
Present.
18, LE18, 18 absent, ma'am. LE19,
Present.
LE20,
Present.
21,
Present, ma'am.
22,
Present, ma'am.
23 present, ma'am. Chat లో చెప్పారు. 24 present, ma'am. LE18 కూడా present, ma'am.
LE18
కూడా present.
4A1 కూడా present, ma'am. Chat లో చెప్పారు. B9, ma'am. B9 కూడా present, ma'am. అంతే మ్యామ్. LE22 అంతే మ్యామ్.
డి సెక్షన్.
Yes, ma'am. I1,
I1 present.
I2,
Present.
I3,
Present.
I4, I4, I5,
Present.
I6,
Present, ma'am.
I7,
Present.
I8, I8, ma'am, I8,
ఓకే.
ma'am, I8 present, ma'am. Chat box letter. I9,
Present.
J0,
Present.
J1,
Present.
J3,
Present, ma'am.
J4,
Present.
J5, J5, J5 chat box letter, ma'am. J6,
Present.
J7, J7, ma'am, J7,
ఓకే.
J8, J8. Ma'am, J8 కూడా. J9.
Present, ma'am.
K0.
Present.
K1. K1 present on chat box like that. K2.
Present, ma'am.
K3.
Present.
K4.
Present.
K5.
Present.
K6. K6. Ma'am, K6 ma'am.
Present.
K6 present ma'am. చెప్పారు. K7.
Present, ma'am.
K8.
Present, ma'am.
K9.
Present, ma'am.
L0. L1.
Present.
L2.
Present, ma'am.
L3.
Present, ma'am.
L4. L4 present ma'am. Chat box like that. L5.
Present, ma'am.
L6.
Present, ma'am.
L7.
ఇందాక K7 ఎవరు ఆబ్సెంట్ K
మ్యామ్ ఇందాక K7 మ్యామ్.
ఓకే ఓకే
L7 present ma'am. Chat box like that. L8.
Present.
L9.
Present.
M0.
Present.
M1.
Present, ma'am.
M2.
Present.
M3.
Present, ma'am.
M4.
Present, ma'am.
M5. 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 Ma'am, M5.
M5
మ్యామ్ K7 ఇందాక చెప్పారు మ్యామ్.
ఓకే ఓకే
M6.
Present, sir.
M7.
Present, ma'am.
M8.
Present.
M9.
Present, ma'am.
N0.
Present, ma'am.
N1. N1 present on chat box like that. N2. N3. N3 present on chat box like that. N4.
Present.
N5. N5 present ma'am. Chat box like that. N6.
Present.
N7.
Present.
N8 present ma'am. N9.
Present.
38.
Present.
39.
Present.
40.
Present.
41.
ప్రెసెంట్
42.
Present.
43.
Present.
44.
Present.
45.
Present, ma'am.
46.
Present, ma'am.
47.
Present, ma'am.
48.
Present.
మ్యామ్ అంతే మ్యామ్ అయిపోయాను.
ఓకే మేడం జాయిన్ అయిపోతారు, మీరు కంటిన్యూగా ఉండండి. ఓకేనా?
ఓకే మ్యామ్.